Hi there, welcome to video number 166. This video is on volume of cones and spheres. Keywords I've got for you are volume, solid and cubed units. Now the volume is the space inside a 3D object, the solid is the 3D object itself, and cubed units are what we measure volume in. So to calculate the volume of a cone or a sphere, you need to know how to substitute into a formula. You'll be given the formula for both. Replace the given value for the appropriate letters in the formula, and you may well need to rearrange to make something else the subject of the formula to work out that something else that you want to work out. Alright, now it's a pretty simple skill, this, for a grade 5 thing to begin with, but it does get more complicated as ever. So let's do the first couple of questions. Alright, so if this is A, that's A and B, keep forgetting to put A and B in some of these questions. What we've got is 1/3 of pi r squared h for the formula here. Now, what's what, basically? So the r is the 3 centimeters at the bottom, all right, and the h is the perpendicular height of the cone, okay? Remember in the last video, if you watched the last video, the slant height was L, all right? We don't have that in this question. We don't need that for the volume, all right? We only need that for the surface area. So 1/3 of the pi multiplied by pi multiplied by 3 squared multiplied by 12. Okay, that's our volume of our cone. We bring a calculator in, we type in the fraction 1/3, okay, multiplied by pi multiplied by 3 squared multiplied by 12, and it is that easy. Okay, 36 pi, so the volume equals 36 pi centimeters cubed, because it's volume, it's measured in cubed units, and then the volume we could write as a decimal if we needed to, 113.097, etc. I'm just going to round it to 113.1 centimeters cubed. All right, now if this is this base is a circle, all right, and the surrounding prism that you could draw around a cone would be a cylinder, okay. If you had a triangle base on this would be a triangular based pyramid, right, and then you could draw a prism around that, right, and that would be a triangular prism. If you had a square base on this pyramid, it would be a square base pyramid, and the surrounding prism would be a cube or cuboid. And the formula it comes from knowing that the volume of the pyramid is always going to be 1/3 of the surrounding prism's volume. Okay, that is a useful thing to know. It's not something you necessarily have to be tested on at GCSE. It's just a nice thing to know. All right. Now B states that the formula is 4/3 of pi r cubed. Okay, so the volume equals 4 over 3, 1 and 1/3, multiplied by pi multiplied by, and again we need to be careful that we don't use the diameter, we need the radius, so that's 9 centimeters. Okay, so 9 cubed. Okay, again we're going to get an answer in terms of pi first of all, but we just type it all in, 4/3 multiplied by pi multiplied by 9 cubed. Don't forget to press cubed. Some people press squared. Made that mistake myself before. All right, so there you go, 972 pi centimeters cubed. Now the volume is equal to, if we wanted it as a decimal, 3053.6 centimeters cubed. Done. Right, so I said it's pretty simple to start off with. And I wasn't lying. It is pretty simple. Just type the stuff into the calculator using the formulas that you will be given in the question. I mean, you might get a hemisphere here, all right, which is half of a sphere, and in which case you would use 2/3 of pi r cubed, or just do all of this and then half your answer. Okay, right. Let's have a look at the second question. So you've got to use the formula to calculate x. This time we're working backwards. X in this first question here is of the cone. X is the radius. That's what we want. So we're going to use the formula again. So the volume we've been given, right, is 152. So that we could write 152 is equal to And again, we would be given that formula, 1/3 of pi multiplied by the radius squared multiplied by the height, which we could substitute the 18 in for, okay, because that is the perpendicular height. And basically, we could write all of this over 3. We could write it as pi r squared, or 18 pi r squared over 3, right? That's another way of writing what we've got on this side. So that is kind of how I'm going to write it, because I think it's just nice and neat that way. All right, 18 multiplied by the 1, multiplied by the pi, multiplied by the r squared. So that's 18 pi r squared over 3, okay? Because they're all fractions and you can multiply them all together, etc. Or put them all over 1. Done videos on that before. So 3 multiplied by 152. Let's bring a calculator in. Let's find out what that is. $456 equals 18 pi r squared. Okay, now we can divide by the 18 pi. This bit is in front of the r squared, right? So divide by 18 pi. I'm going to put the 18 pi in brackets because it might work out incorrectly if I don't. So there we go. That's going to be 8.06. 8.06 ... is equal to the radius squared. That hasn't found us x yet because x is the radius. So all we need to do with our answer is square root the answer. So square root that answer equals 2.83. I'm going to round it off to 2 decimal places, so 2.84. So r equals 2.84 centimeters. All right, ran out of room a little bit there. All right, but in stages, I've written down the volume and then the formula for the volume on the other side. I've worked out what I can on this side, clumped it together. I've done my solving equations business, multiplied both sides by what I needed to, got this, then divided both sides by the same thing, and then square rooted. So it's just solving an equation. Once you've got the numbers in, you just solve the equation, you get the right answer. Okay, now that's an approximation because I haven't rounded it, it's not exact, right? So if you type that back into the calculator, you wouldn't get exactly 152 because I'm very, very close to 152 centimeters cubed. All right. Now let's try the next one. X in this instance is the diameter. All right. So we don't have the diameter in the formula. I'll just write the formula up here. 4/3 of pi r cubed. Okay. Now, that looks a bit awkward. I'm going to rub that out. It looks terrible. 4/3 of pi r cubed. Basically, you just use the formula again. So we're gonna go with 40 for the volume equals 4/3 multiplied by pi multiplied by the radius cubed. All right. Now what I was talking about earlier, putting over these over 1, multiplying it all together. All right. 4 times by pi times by the radius cubed. 4 pi r cubed over 3 times 1 times 1 is 3. Okay. That's what I was talking about in this question, right? I didn't make it explicit there, I don't think. So 40 times by 3 is 120 equals 4 pi r cubed. Again, do the same thing. Divide by the 4 pi that's in front of the r cubed. So let's just get the 120 on the screen. Divide it by, and I'll do that again in brackets. Just the safest way to do it. Depends on what calculator you've got. It might work out without doing it in brackets, but 9.55 or 9.54 etc. Is what r cubed is. So 9.54 ... equals r cubed, and again we need to just undo the cube nature of that answer and cube root it. Okay, so shift cube root, the answer equals 2.12. Okay, so r equals 2.12 ... But don't forget, we don't want r, we want d, we want the diameter. So x equals, all right, the diameter is labeled as x here. I should have labeled that answer x as well in that first question, technically. All right, we just times that answer by 2 because diameter is double the radius. So 4.24 is what I'm going to round it to. 4.24. and that would be in centimetres. All right, I have to go all out the box there because there's a lot of stuff going on, I am aware, but you follow that, it's not too bad. You're just using the formula. All right, definitely top end of foundation though, for sure. Okay, right, let's have a look at the third and final question on this particular topic that I've made. So a cone and sphere have an equal volume. The radius of the cone is 5 centimetres and has a height of 40 centimetres. Find the radius of the sphere. Answer to 2 significant figures. So the cone and sphere have an equal volume. That's good. We know the formulas for the volume. We'd be given those again in the question, like I said, but I haven't written them down in the question again because we've got them on the page in front of us. So I'm going to substitute in the things that I know. The radius of the cone is 5 centimetres and it's got a height of 40. You could draw a sketch if you wanted to of the cone, but I'm not going to, because I'm going to do 1/3 multiplied by pi multiplied by 5 squared multiplied by 40. Okay, that is the volume of the cone. All right, that's all in numbers. Everything there is numbers, so we can actually work that out, find out what it is. All right, so 1/3, I'll just write down what it is afterwards actually as well, multiplied by pi multiplied by 5 squared multiplied by 40 equals 1000/3 pi. So the volume of the cone, that is, isn't it? Yeah, that's the cone. So the volume of the cone equals 1000/3 lots of pi centimeters cubed. I can put that on there, doesn't really matter at the moment because we haven't finished the question. We've got to find the radius of the sphere. Okay, so we know the sphere has got this same volume. The volume of the sphere is the same thing because it says that in the question. Okay, they have an equal volume. So 1000/3 pi, all right, is the volume of our sphere. And the formula for the volume of a sphere is 4/3 multiplied by pi over 1 multiplied by the radius cubed over 1 as well, like I did earlier. Okay, and then that would equal this 1000/3 lots of pi, right? So let's collect all this together that we've got on this side again. So we've got 4 pi r cubed over 3, which equals 1000/3 lots of pi. Basically, we could put that pi on top there actually as well, just to tidy it up to make it not look like it's part of something else. All right, there's our pi on top because that's, again, that's just multiplied by pi over 1. All right, so that's just 1000 lots of pi over 3. Multiply both sides by 3, you get rid of the divided by 3 on both sides. So we've actually just got, and I'll write it over here, 4 pi r cubed equals 1000 pi. And then you can see that there's pi on both sides, so you can divide by pi. That cancels the pi on both sides. And then you've got 4r cubed equals 1000. Okay, and then divide both sides by 4, you get r cubed on its own there. And that's going to be 250 if you divide by 1000. So divide 1000 by 4. And then 250 cube rooted is all we need to do. So 250 equals, and then shift cube root, the answer equals, 6.29. So r equals 6.29 something something something, but I'll round it to oh, that's annoying, 6.3 I'm going to round it to. Didn't really pay attention to what the next number was, but 6.30 would be a good degree of accuracy to round that off to, and that would be in centimeters. Okay, now we could always check to see if that gave us a sensible answer, right, by substituting it back into the formula. It doesn't take long to do that. So 4, just like the first question, 4/3 multiplied by pi multiplied by the radius cube. So let's just put in 6.3 and see if it gives us something near to what we think it should be. And then we'd have to check to see what 1000/3 lots of pi was. So remember that number, right? And then 1000, a bit more awkward than I thought it was going to be actually. 1000/3 multiplied by pi equals that. Yeah, so it's a very, very similar answer. So yeah, we're pretty confident that is definitely the right answer. Okay, so a little bit trickier. You might get something more complicated than that. And what I've actually got for you on this one is a bonus question. All right, so the bonus question is not going to be brought to you by me. This is brought to you by my friend SCIMANDAN. So please do pay attention to the next one, because I think it's a nice question. I wrote it for him specifically with him in mind, because he's a bit of a science boffin. And yeah, he's got his own YouTube channel, very, very successful YouTube channel, but a good friend of mine for a long, long time. So over to Dan. Thank you so much for watching this one. Enjoy the next bit.
Hi there, my name is SCIMANDAN. Thanks very much to Bear Maths for letting me have a little go today, and we're going to help with a volumes of cones and spheres question. And the question is this: the volume of the moon is approximately 2.19 times 10 to the 10 kilometers cubed. The Earth's core has a radius 0.7 times the size of the moon's. Calculate the approximate volume of Earth's core. Well, the first thing I would do here is I would use the formula we've got here, the 4/3 pi r cubed formula, which is our volume of a sphere. And I'm going to rearrange it so we can find the radius. So the way we're going to do that is we're going to do a little bit of rearranging the equation. So first thing I'm going to do is I'm going to write out 2.19 times 10 to the 10 equals, so that's our volume of the moon in terms of the sphere, 4/3 pi r cubed. Now the first thing I'm going to do is I'm going to multiply everything by 3, so it cancels off this 3 here, and that's going to give us 6.57 times 10 to the 10 equals 4 pi r cubed. The next thing I'm going to do is then divide both sides by 4 pi. That will cancel off this. So that will give us 6.57 times 10 to the 10 equals r cubed. And then I'm going to cube root everything. That's going to get rid of that cubed. So r is going to equal the cube root. This should be 4 pi under there. So the cube root of 6.57 times 10 to the 10 over 4 pi. Okay, so that's going to give our radius of the moon. Now we plug all that into the calculator and it gives us an answer of 1,740 kilometers. Notice I've stuck to the 3 significant figures because the question was in 3 significant figures as well. Okay, cool. Next bit. Okay, now that we know the radius of the moon, which is 1,740 kilometers, I'm now going to take this value and I'm going to multiply it by 0.7. Now I'm going to do that because we know that Earth's core is 0.7 times the size of the moon. So 70% basically. So if we multiply that by 0.7, it gives us an answer of 1,218 kilometers. Perfect. Now we've got that, we can go back here to our volume of a sphere calculation and we can input our value of our new radius for the Earth's core into the calculation. So it's 4/3 pi, and then we're going to put the radius of the Earth's core in there and we're going to cube that. Now we plug all that into the calculator, it gives an answer of 7.57 times 10 to the 9 kilometers cubed. And there is your answer. Cheers, see you later.